Hello all, welcome back. Today we are here to discuss about a question called valid anagram question. Question number 242 from lead code, which is one of the base question for many other problems. This will help you understand how your hash map works, how you need to use your strings and how you need to manipulate and all the things. Mostly it covers many things, guys. So let's discuss one by one. So let's see first what is the question about. So given two strings s and t, return true if it is an anagram of s, if T is an anagram of S, or else false. So very simple, straightforward thing, nothing much to discuss here. There are two strings, S and T. If S is an anagram of T, return true. If not, return false. Very simple thing. But before that, what is an anagram? What is an anagram? That's the main thing that we need to see here. Okay. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, using all the original letters exactly once. So anagram is nothing but it's a word or a phrase. It can be a phrase here. Formed by rearranging the letters of a different word using all the original letters. They're not calling characters here, guys. Observe it carefully. Okay, usually what we call it is our like every character, but they're not calling character here, they're calling it letters. Observe this point carefully. So an anagram is a word or a phrase formed by rearranging the letters of a different word. So there is a word, by rearranging the characters of that word, anagram is formed. And we should use all the original letters exactly once. So I hope you understand what is an anagram. If not, let me take an example for you people. So let's take, there is a string called, let's take one string, MOVIE. There is a string called movie. This is the original string. Okay. Let's call it as a S. Now let's form an anagram. How you will form an anagram T? How you will actually form? I'm just taking this example case. These two strings are originally given in the question itself. I'm just explaining how anagram is formed. So all the characters are rearranged. It can be rearranged. It can be same also. Rearranged. Let's assume rearranged. And every character should appear at exactly once. Those are called as anagrams. So let's take MOVIE. So I'll take AIMVO. Now these two are called as anagrams. These two are called as anagrams. What if I have EMOVI? Now, is this an anagram? Yes, obviously. Why not? Every character, M is exactly at one time, O is exactly one time, V is exactly one time, I exactly one, E exactly one. What if I have two I's? Now, is this an anagram of this kind? Is this true? No, that is not an anagram because I is repeated twice. I is repeated twice. It should not be the case. So the first most thing is original string and anagram string, their lengths should be same. If the lengths are different, then there is no way that they can become an anagram. Okay. If the lengths are same, we need to validate like this. Whether each character is exactly present once or not. Letter, not character, letter. So now I hope the anagram definition is clear now at least. Now let's take one more string. S equals to A, B, A, A. Now let's take T. Let's take T as A, B. Is this an anagram of S or not? Come on, guys, think. Is this an anagram according to the definition of anagram? Is this true? No. Why? Why? Because in the anagram's definition, what this is, each letter should be at least exactly once in the T string. Now, A. How many times we have A here? Three times. But do we have same three times in T string also? No, it is only one time. So this is not a anagram. So the anagram will be like this. It can be A, B, or B, A, A, A. It can be anything, guys. You can form with these alphabets. So at the end of the day, whatever original string contains, how many times we have A, how many times we have A? We have A three times. How many times we have B? How many times we have B? We have one time. So the same thing we should be there for your T string, another string also. If then there is a possibility that this is anagrams. I hope you understand this one. And I hope you understand what is the purpose of using hash map also now, right? At the end of the day, we need a frequency of each character. Frequency of each character. Why we need a frequency of each character? Because by using that frequency itself, we can say there are anagrams or not. So that's the reason we use a hash map here. So let's take one example and we will do it with a hash map. S equals to A, B, B, C, A, and T equals to B, C, A, B, A. Obviously, you might have known the answer. These are anagrams, but let's still take one hash map now. I will iterate on my original string. It's a A. How many times I have A? One, two times. But every time why I will run a for loop. I'll go to A character. I'll put hash map. In the hash map, A is how many times I have A? Initially, I know only it is one time. Okay, I know A is exactly one time. Now I'll go to B character. B, B is also one time. B is also how many times we have B till now? We have one time. Next, I'll go to next character. What is the next character? It is B again. Do I have already B? Yes. So then update it with 2. Update it with 2. That's all. Now next C. Do I have C? No. So create for C. C is 1. Next A. A is already there. So update it with 2. This is how your hash map will look like after iterating on string S. String S. Here, what you can do is you can create one more hash map for T string to store frequency of T string. Okay, what you can do A is how many times? 2 times. B is 2 times. C is 1 time. Now compare these two hash maps. If they are matching, done. If not, then there is an issue. This is how you can do one way. Or else, if you think why we need to extra space, I don't even need an extra space. Then what you can do? You can simply go to B character and reduce this with 1. And C character, reduce it with 1. So it will become 0. A, reduce it with 1, it will become 1. B, reduce it with 1 now again, 1 will become 0. A, it will become 0. So whenever it is having all characters exactly same as your original string, everything will become 0. So in this way, you can even avoid extra space for hash map also, guys. I hope you understand this one, what we are doing. So when S string S string frequencies are same as T string, how many times it has been increased, the same number of times it will be decreased, which means plus 5 and let's take simple maths, plus 5 and minus 5. What it will become? What it will become? Obviously 0, which means both are same, right? So the same simple math, guys. How many times we have A? If the same number of times we have A here, it will reduce, it will increase by 2 and it will decrease by 2, which will make it neutral, 0. So and then I can simply iterate on this hash map. I'll check whether all are zeros or not. If all are zeros, that's fine. Good. It's a hash map. It's an anagram. If not, it's not an anagram. So this is what we need to do. So as the first thing, let's start our coding as a first thing and let's create a hash map. What should be the type of hash map? So it should be a character and what we need to store, its frequency. It is an integer. So hm equal to new hash map. Okay. Now what we need to do, iterate on your first s string. So int I equal to 0, I less than s dot length, I plus plus. Now after going to character, char c equal to s dot caret ith place. What is a character? Get the character. And now update your hash map. Hash map dot put where for which character you are putting the frequency for the current character. What will be the frequency? It will be +1. But what if it is already there? So that's why hash map dot get or default. Get or default if it is there for the correct character. So let me break down this guys for you people. So what I'm doing here, as we know that whenever there is a so let's take an example here parallelly ABC. Whenever I encountered B, what I need to do, I need to go into my hash map and update it with 1, right? If I see A again, what I will do, update my hash map 1 with 2. This is what we need to do. So we need to update for current character. Okay, but for the first time, do we have anything in my hash map? No. So what will be the A's frequency? It will be 0. So instead of checking, we can even do this with another way, guys. We can use hashmap dot contains key. Hashmap dot contains key method. We will check whether it is already there. If it is already there, what is the purpose of creating a new one? Okay, if it is not there, then we will update the frequency. That is one way. But here what we are doing is we are simply using the get or default method. So if the key is present, if this key is present, let for example, a value is already there. A value is already present as 1. What it will do, it will get this value as 1. If the key is not present, then it will get the value as 0. So that is what here default means. So either get the keys value. If the keys value is not there, give me the default value as 0. Why I need to take 0? Because initially nothing is there. So that's the reason we will take it as 0. And whatever we get, we will add +1. That's all. Simple thing. I hope you understand this particular line. And after that, we will simply copy the same thing. We will paste it again. We need to iterate on our t string. T dot caret I. If it is there, what we will do, we will decrease the frequency. Why we have decided to decrease the frequency? As we know, +100 and -100, they are equal to 0. So in that proper maths, we are doing it here, guys. Now we need to check the hash map. How you will check the hash map for int frequency colon hashmap dot values method. We have a method called hashmap dot values, which will get all the values of your hash map irrespective of the key. If your frequency is not 0, if it is not 0, what does it mean? There is a point that the character can be more in first string or characters can be less in the second string. So that's how it is. So then return false. If not, what you can do? Return true. That's all. That's all, guys. So as we have already seen, if all the characters are 0 in your hash map, then this is true. If there is at least one character where it is 1, this is not a true because there is one more character which is not properly mapped. So let's take an example, invalid example. Let's take A, B, A and A, B, C. Okay. A, B and ABC. Let's create a hash map for ABA first. Let me take another color for you people. So for A, what is the count, guys? For A, it is 2. For B, it is 1. Right. Now I'll go to A. This will become 1. Now I'll go to B. This will become 0. Go to 1. Now I'll go to C. Do we have C in this my hash map? No. So what it will become? C will become -1 because of this particular condition. So we are getting default value as 0. If it is not there, I'm doing -1. So that's the reason it is minus. Now I will check in my hash map. I'll go to first character itself. Is it completed? It's 1. What does 1 means? Because there is one A missing. We only have one A, but in our original string, we have two A's. So I should have a frequency of A as 2. If it is 2 in the second string also, 2 minus 2 will become, what it will become? It should become 0. If it is not 0, if it is any other value except 0, what does it mean? There is a mismatch in the frequency of the characters. That's all. That's the reason we are returning false. If there is match, if there is a match, we should still check in the complete values, complete hash map values. So that's what we are doing. If everything is proper, at the end we will return simply true, guys. This is what we need to do. I hope you understand the logic here. So this is how our anagram question works. So, okay, unexpected. Oh, my bad. We need to take your character, integer. Now let's run this one. Yes, that's all. I hope you understand this question clearly, guys. Let's meet in the next video. Until then, tata.